In this video, we're going to look at data visualization in Python. Now, the main module for visualization in Python is Matplotlib. Now, within Matplotlib, there's the PyPlot module, which which gives us a convenient way to generate the type of plots we want. And then we'll also be using Seaborn, which stylizes our plots quite nicely. Now, in terms of data generation and manipulation, we're going to be using another major module that is typically in the data scientist toolbox, and that is NumPy. So we're going to begin by looking just at the standard imports for using PyPlot and NumPy. So these are just conventions. So for importing PyPlot, we're going to import it as PLT. NumPy is going to be NP Seaborn SNS, and the statement over here initializes Seaborn. So what is NumPy? So NumPy is a really powerful library for generating and manipulating collections of numerical data. Now, the main construct within NumPy is a NumPy array. And the NumPy array represents data in numerical data in multiple dimensions. So it's quite powerful, and it's the whole library is written in a way that is very optimized for manipulating large data sets. Now here we're just going to look at a couple useful examples with NumPy just to generate some data. So the first function we're going to look at is linspace. And what linspace does is that it creates an array of evenly spaced numbers over a given range of values. So here's an example of using it. So here we're creating a NumPy array called X, and we call linspace, and then the first two arguments to it give us the interval, so from 0 to 1, and both 0 and 1 are included, and this is how many values we want to create. So in essence, what we've done is created 10 values within the range 0 to 1 that are evenly spaced, and that's what we see over here. Now, notice that when I print out my NumPy array, the values are just separated by spaces, whereas with a list, the values would be separated by commas. So this is an easy way to just detect that what you're working with is a NumPy array as opposed to a list. Now, given a NumPy array, we could apply any of the standard arithmetic operations on it, except here the operations are applied element-wise. So what do I mean by that? So suppose, given our NumPy array X, if I were to add 2 to it, what this will do, it will add 2 to each element in X. Okay, and then the result will be stored in this new NumPy array Y. So the result we get here is this is Y displayed over here. Now we could, here's another example of just constructing another NumPy array Z, and Z is defined as X times 3 plus 5, so plus 5. So again, we're multiplying each value in X by 3 and then adding 5 to it, and this is the result. So these operations are referred to as vectorized operations. So if we think of the array as a vector, then the operations are applied to each element in the vector. So this is just terminology. Now, if we were using a list and we want to achieve the same thing, then we would what we need to do is using loop iterate over the list, and for each element we're gonna add the value or subtract the value or multiply. So in this case, without a loop, we're just achieving the equivalent outcome, but it's much more efficient than a list. It's usually about 50 to 100 times faster than doing it with a loop. Okay, another couple examples. So one is how we would go about creating a NumPy array with random values. And the range of random values is 0 to 1. So in this case, 0 is included and then 1 is excluded. That's what the parentheses here indicates, that 1 is outside the range. So the function to do that is the rand function. So with an argument of 10, what I'm specifying to the function that I'd like a single dimensional array of 10 random doubles to be generated, and this is what I get. It's also possible to generate a two-dimensional or an n-dimensional array of values. So this is an example of generating a 4 by 3, so 4 rows, 3 column NumPy array of random values, random doubles. I could also create an array of random integers using the function randint. Now with randint, I need to specify a couple parameters. So the last parameter I specify over here, size equals 5. So this is how many random integers I'd like to generate. And then the 5 is the maximum value, so which is excluded from the range. So in this case, if I don't specify minimum value, so it's gonna start at 0 and it goes up to 1 less than the value specified here. So this is gonna give me something in the range 0 to 4, where the 4 is included. So here's possible output from the statement. And in the second example, I'm generating an array of 10 random integers, and then the minimum value is 20 and the maximum value is 29. So 30 is excluded again. So here's a possible output. Okay, now we're going to move on to looking at Matplotlib. And we're going to start by generating line plots from a set of discrete points. So to generate the discrete points, we're going to use linspace. So we have 30 points within an interval equally spaced within the interval 0 to 30. So even though the points are discrete, when I use plot in the manner it's used here, it's just gonna draw a line connecting these points. So plot in its simplest form takes the values on the x-axis and the values on the y-axis. So over here, I specify the x values to be what I have in x from 0 to 10, and then I specify the same values for the y. So in essence, this is plotting the function y equals x. Now, this corresponds to this plot over here. Just one thing to note is that the scale on the x-axis is different than the y-axis. This goes 0 to 10, and this is on the y-axis, it's 0 to 40. So this is indeed has a slope of 1, which is what we'd expect when we plot y equals x. Now, in the second plot statement, over here, we're specifying that we're plotting y equals 2x. That's what we have. And I'm going to plot it in green, but and the line style is a dash dash. So that's what I have over here. And the third plot is the red, and this is dot dot, and then the slope is 3. So that's that over here, and then the cyan. Let's see if we have something close to it. Well, let's use some other color for it. Let's use purple to represent cyan. So so that's this over here, and the line style is dash dot. And then we've also specified that the line width is 3. And then finally, the last plot, we're plotting a sine wave. So we call sine on the array we generated. So that's plotted on the y value, on the y-axis. So that's what we get over here. So as you can see, with very little code, we could generate some nice looking line plots. Okay, now using plot, the method plot, we could also generate a scatter plot. So scatter plot is one where we plot the points in the input as discrete points on in the figure, and we do not connect them. So we could do that quite easily. So in this example, I have my X array as before, and I have two arrays, y1 and y2. y1 corresponds to the sine wave, sine function, and then second one is the cosine. And here I plot y1 and y2, and to generate a scatter plot, I'm specifying the symbol corresponding to each of the data points. So for the sine wave, I'm going to use the O and then the X for the cosine. And then I specify the color, and I'm also attaching a label to each of these plots. So as you can see, I have my plot with the sine and cosine function, and by assigning the label and calling the legend method, I've generated a nice legend here, so I could interpret the figure correctly. Now, there's an alternative way, perhaps the more standard way of generating scatter plot, and that is using the scatter method. So I'm going to first show you an example of how to use scatter. So, the same X array and Y1 is the sine wave, and I just call scatter with X and Y values, and I get a sine wave out. So in essence, this generated something I could have done with plot, but as it turns out, scatter is much more powerful in that it allows us to control the styling of each individual point. So I'm going to show you a quick example just to give you a feel of what you can do with scatter. So whereas plot, it's a bit more limited. It's more efficient if you have a very large number of points that you want to plot, you would use plot, but scatter gives you a bit more control. So let's look at an example. So here we have a data frame containing data about 5 cities. So those are in the first column. And I have the GDP for each city, the population, and the area. So I have 3 columns that are numerical, and let's say I'd like to represent those, plot those using scatterplot. Now scatterplot is intrinsically a 2-dimensional plot. So how can I use it to represent 3 dimensions? So one idea would be to have, let's say, GDP on the y-axis, the population on the x-axis, and the area. The way I'm going to represent area is I'm going to have the symbol corresponding to each city to be proportional to the area. Okay, so what I mean by that, this symbol for Tokyo, let's say, is going to be larger than the symbol I use to represent New York, because the area of Tokyo is larger than New York. So in that way, I've represented 3 dimensions using a 2-dimensional scatter plot. So let's see how I'm going to do that. I'm not going to get into a lot of the details. So let's first look at the output, what we have. So again, on the x-axis, I have the population, the GDP on the y-axis. So you can see London roughly has population of 8 million, GDP, somewhere around 700 something billion. And, each of the circles that I'm using, the size of the area of each circle is proportional to the population of the city. So very easily you could see that Tokyo stands out as having the largest area. And it also has the largest GDP, but its population is second after Seoul. So let's see how we'd go about that. So I'm just going to point out a couple things in here. So first, the size of the symbol I'm using, which is a circle, to specify that it's proportional to a column, I use the argument S for size. And so the sizes are drawn from the area, that's the column in my data frame. The alpha value, 0.2, corresponds to the transparency of the color of the circle. So the smaller the value, the more transparent the color is. So if this, and then alpha is a value between 0 and 1. So if 1 means it's completely opaque. So that's what the alpha value is. And then this for loop over here is essentially associating the label, which is a name, with each of the circles that correspond to the data points for a city. So that's what the for loop is doing. But again, this is just to give you a sense of what you can do with scatter. Okay, so moving on, and this is something we've seen before, histogram, so this is a little bit of review. So histogram is a plot that shows us the distribution of a variable, in that it gives us the frequency with which some range of values occurred. So the data that we're going to use here is a normal distribution. Now, this is not something we've really talked about, but even if you haven't had a course in statistics, you know that the normal distribution is bell-shaped. That's a bell curve. So here I'm generating normal 10,000 points from a normal distribution with the mean, the average value is 0. So you could see that over here. And the standard deviation, so this is a standard deviation, is 1. So the mean, let's erase this. So the mean is the first value and the standard deviation is the second value, and this is the number of points. Okay, so given 10,000 points from the normal distribution, if we were to plot them using histogram, what would that look like? So that's what we would expect. Number of bins over here is 20. So the bins is how many intervals uh, do we break up the range of values? So it's 20. So the greater that number is, the narrower each of these bins is, each of these columns will be. Okay. Now we could, I'm going to show you an example of where we stack multiple histograms. So let's suppose you have two variables that you're trying to compare to each other. So you would stack the histograms. So the quick example here is using two arrays, data 1 and data 2. They're both normally distributed, but they have a different mean and distribution. So data 2 has a mean of 5, standard deviation of 2. The other one, data 1, has a mean of 0, standard deviation of 1. So we'd expect data 1 to be narrower spread with a mean of 0. So that's the blue here. Mean of 0, narrower, that's a smaller standard deviation, and data 2, the mean is 5, and it's a broader distribution because the standard deviation is larger, it's 2. So, so here we plot those two with bins set to 40, the alpha value is 0.6, and that's nice because it allows us to see the overlap between those two distributions. Now, the last type of plot we're going to look at is a bar plot. So histogram shows us the frequency of values, and on the x, when we're dealing with a numerical variable. Okay, so again, on the x-axis, we're dealing with numerical values. Bar plot, on the other hand, allows us to compare different categories. So the x-axis or the y-axis is a category. So let's look at an example. And here we're referring to the same data frame we looked at earlier. So we want to create a bar plot that allows us to compare the populations of the various of the 5 cities we have. So for each city, we're creating a bar. And on the y-axis, we have the population. So this is pretty simple, and it allows us to quickly, recognize how the cities compare to each other relative to this variable over here. So the bars, the names of the bars are drawn from the names columns from the data frame. The height is the population column, and then the positions, we need to specify how many bars there are. So there are 5, so we're going to create a list from 0 to 4. So that's what we have over here, and then we plot the bar plot, and then we modify the x-ticks to be the names of the cities, and then we set a y label that's over here. Okay. Now, just look at another example, it might be useful to look at a horizontal bar plot. Might be preferred in some cases. So if we want our bar plot to be horizontal, we could use the function bar h for horizontal. So here the only difference is that I'm defining y position instead of x position. I'm defining y ticks instead of x ticks, right? Because the categories are on the y-axis now, not on the x-axis, and then the population is the x label. So this label is over here. That's the x label. And then additionally, I'm assigning colors to my bars. So here they are. I have a list of colors. So it looks pretty colorful. So again, it's representing the same information, just whether you prefer it to be represented vertically or horizontally, it doesn't matter. But it's, as we can see, it can be done quite easily um, with Matplotlib. Now, I would encourage you to look at some resources online that show you many, many more examples of visualization. So here are a couple great resources. The tutorial for Seaborn is quite good, so take a look. The examples are really impressive. And then here's another one, uh, Python graph gallery. So with that, I'm going to conclude. So thank you, and